strategy for factoring called factor by grouping, and this is kind of the second wave of defense in factoring. First, you want to look at greatest common factor, and we need to understand greatest common factor in order to do these. And also, I think it's also important for students to remember that factoring turns addition and subtraction expressions into a multiplication expression, and that's very powerful. So the way factor by grouping works is, you notice, for example, my first example here, x squared plus 3xy plus 3y plus x. We have four terms, so that's kind of the tip that I need to do factor by grouping. And I have no common factors in these four terms. There's nothing that exists in all four terms. So my next strategy is I'm going to do something called grouping. And what that means is I'm going to group my first two terms together and my second two terms together. Now in doing so, hopefully my two terms, now they each have their own common factors. So for example, my first two terms, I have x squared plus 3xy. They have a common factor of x. So if I take out an x, I'm left with an x plus 3y, and that's factor by greatest common factor. You need to make sure you understand that. The second group doesn't really have a common factor, but just for the sake of our notation, I'm going to write the number 1. I factored out a 1, and I'm left with 3y plus x, which, by the way, is the same as x plus 3y. And so now if you notice, I have two terms. These are my two terms, and my two terms have a common factor now, and the common factor is x plus 3y. So if I factor out an x plus 3y out of my first term, if I factor an x plus 3y out of my first term, I'm left with an x. And if I factor it out of the second term, I'm left with a 1. And now look, I've turned an addition statement into a multiplication statement. It's factored. Okay, let's try this again. This time we're going to look at example B, which says a cubed plus ab minus a squared b minus b squared. And so notice we have four terms, and these four terms do not have a common factor. So we look to grouping. I'm going to group my first two terms, and I'm going to make a mistake here that is very common, that I see a lot, and that's grouping the second two terms. But when I group them like this, I've made a mistake because remember now that this negative symbol is being distributed across here. So I've changed the problem, and I don't want to do that. So I'm not going to group it like this. Instead, I'm going to rewrite this expression to say a cubed plus ab as a group, and then my second group is plus negative a squared b minus b squared. Now in doing that, I have fixed the problem, and I don't have to worry about distributing that negative. Okay, so in my first group now, I can take out an a, and as I do that, I'm left with a squared plus b, and that's just greatest common factor factoring. In my second group, I can do the same thing, and this time I can take out a b, but I could also take out a negative. So I'm going to take out a negative b, and when I do that, I'm left with a positive a squared as my first term, and a positive b in my second. And now notice, just like in example A, I have two terms, and they have a common factor. The common factor is a squared plus b. And if I factor that out of my first term, I'm just left with an a. If I factor it out of my second term, I'm just left with that minus b. And so there it is, it's factored. A squared plus b times a minus b. Okay, and again, if you have the subtraction here at the end and here in the middle, you need to make sure that you rewrite it first so you don't make that double negative mistake. Okay, now let's look at part C here. And we're going to just do the same thing again. This time I have 3ac minus 5 by bd plus bc minus 15ad. And you notice I don't have any common terms here again. And actually, if I group the first two terms together, they don't have any common terms either. So I think it'd be smart if we rearrange this to say 3ac plus bc. So I traded positions here, plus a minus 5bd minus 15ad. Now hopefully this will work well when we factor by grouping. So my first two terms, notice I do have a common term of c. So I take out the c, and when I do that, I'm left with 3a plus b. In my second group, I can take out a d, but I could also take out a negative 5. So I take a negative 5d out, and when I do that, in my first term, I'm just left with a b, and in my second term, I'm left with a positive, let's see, 3a. And now notice 3a plus b and b plus 3a are the same thing. And so that's my common factor out of these two terms. I can take out a 3a plus b. If I take it out of my first term here, I'm just left with a c. And if I take it out of my second term here, I'm left with a minus 5d. And there it is. It is now factored. I've turned an addition question into a multiplication question. Factor by grouping, honestly, it doesn't show up all the time, but it is extremely useful, and you do need it. Please, I hope this makes sense. If you have any questions, let me know. I'd be glad to help, and thank you for watching.